So in this case, we are going to have a continuation still on our trigonometry, working with the identities. Remember, we managed to work with the simplification of the identity, working with the tan of theta, where the tan of theta is equal to the sine of theta over the cos of theta. So if you're using x, if you're using theta, it's up to you the way that you present. This is the tan, and also from the Pythagorean identity, which is the sine squared of theta plus the cos squared of theta, which gives us a 1, which is equal to 1. So we are going to see that in the simplification part, you were just given a certain trigonometric expression. Let us just say what we have, sine of x times the cosine of x times the tan of x. The question was for you to simplify. The question was for you to simplify, and you had to apply where these identities can be applied, where it is applicable. Remember this part. So the difference now that we have when the question is on to prove a certain identity, guys, the difference that you are simply having, all right? So I want you to properly see this part. The difference, we want to see the difference there that we are having. So the difference, guys, is that the proof you are given an answer already. You have an answer there. That is the difference that you have. You're already given an answer to say this is your answer. Previously, you were just simplifying and you have answer up to the simplest form. But in this case, your simplest form, the way that you have it as a simplest form, can further extended. So this is what we want to see. They gave us a certain answer. We are supposed to simplify the same way that we used to simplify. But we are supposed to show that our answer is this. All right, so this is just a continuation, guys. As we can see, there's nothing that is new. So on question number 1, we are given sine of x times the cosine of x times the tan of x. So this is equivalent to 1 minus cos squared of x. So we are going to choose which side to work with. Are we going to prove that this right-hand side is equal to the left-hand side? Are we going to prove that the left-hand side is equal to the right-hand side? So it is up to you. So it is best that you always choose the complicated side. The one that is what? Much complicated. Where there are a lot of what? Trigonometric terms. Like as we can see on the left-hand side, there are so many terms that we have. So we can choose to work from the left-hand side. So choosing our left-hand side, this is what we have. We write everything as it is. On our left-hand side, we've got the sine of x, cosine of x, and the tan of x. So from this, is there anything that we can replace with any of this part? We do not have anything that is squared, like sine squared or cos squared. So meaning to say this part, we cannot use it for now. But there is a tan here. We know that the tan is equivalent to the cos, the sine of a cos. But there we are talking of what? X. So we're going to use it as sine of x over the cos of x. So we can get rid of that, guys. This tan here that we are seeing here. Try by all means to reduce all the trigonometric identities that you have and the ratios. So meaning to say we are going to have the sine of x times the cosine of x times this tan written as sine over cos. So it's going to be sine of x over the cosine of x like this. So take note, this is under a product multiplication. This is just same as we've got over 1 like this. So that you can properly see, guys, if you're multiplying, you know that the denominator to the numerator concept or the numerator to the what? denominator you can cancel. So this and this can be canceled. The cos and the cos. So meaning to say we've got a 1 and a 1 here. So multiplying this, guys, what were we going to have if we were to multiply sine times sine? Remember, we can only multiply the numerators together. So it was going to be sine times sine, which is sine squared of x over what? Over 1. Guys, over 1 it means just going to remain as it is like this. So guys, if it was a question where you are being asked to simplify, your answer was going to be this. You're going to leave your answer here. But now, because the proof, it is someone who is working this question and they want you to write the way they presented their answers. But if it was to simplify, I was going to leave my answer like this and say, I'm done. It is in simplest form. But the proof now you must follow to say, is it what you're given here? Here, is it what you're given? It is not. What happened? We just applied this same identity. If we check here, the sine is squared here. If you make it the subject, we're going to take the cos to the other side. So it will be 1 minus cos squared. So this is exactly what we have. So it is 1 minus the cos squared of x, which is exactly what we see here on our right-hand side. So we are proving two sides to say the left-hand side here, what we have on the left hand must be equal to what we have on the right-hand side. So you choose one side. All right. So in our case, we worked from the left-hand side. So our answer is supposed to be exactly the same. Not to say you tell it in your mind to say it is the same and you leave it there. No. To prove it is like show that. Show that. You are supposed to exactly show this on your final answer. Exactly the way it is. So this is it, guys. So you can see we have got our right-hand side from here. Let us see another part. So guys, we just need to work as much questions. Like I always say, guys, do as many questions as you can. Then if you're to consider on question number 2, we are given, that is the cos cubed, this and that. So guys, let us just choose to work with what? The left-hand side. So taking the left-hand side, because it is most complicated side that we have there, it is equal to what? The cos cubed of x plus the cosine of x times the sine squared of x. So we are supposed to show that our answer is cos of x. In this simplification, our answer is supposed to be what? The cosine of x. So let's prove, guys. Let's see what happened here. As we can see, there's something about the cos of x, and the cos of x. It is just like in our algebra. It is just like we're given x to the exponent of 3 plus xy squared. Guys, you can factorize. X is common, is the highest common factor. So you can factor out x, and we've got x squared plus what? Y squared. It is the same thing even under our trigonometry, guys. That algebra part, it was preparing us for those typical questions like what we see here. This is a single term, and this is a single term here. It is a single term. So of these two terms, we can see that cos is common. There's a cos here. There's also a cos. So which one is going to be the highest common factor? The one with the smallest exponent, which is this one. So we are going to factor out the cos of x. What are we going to have? The cos cubed divide to this one. What are we going to have, guys? There are 3 of them. It's like cos of x times the cos of x times the cos of x. There are 3 of them. Over what? Over the cos of x. So if you cancel 1, we are going to remain with what? 2. So it's going to be what? Cos squared. There are 2. Cos times cos. So guys, just know, guys, if there are 2, if there are 3, if you're dividing, subtract 3 minus 1, that's a 2. Guys, I don't know how you can get this one, but guys, all right. The way that you understand is best. All right. Plus, we factor this one, the cos of x and the cos of x definitely was going to cancel. This one, it was going to cancel. Then you remain with what? The sine squared. So you're going to remain with the sine squared of x. This is it. Guys, if you said the sine squared of x plus the cos squared of x is equal to 1. Is it different when I say the cos squared of x plus the sine squared of x is equal to 1? It's not different. A plus B, B plus A, I haven't changed anything here. So given cos squared plus sine squared, or starting with the sine squared, adding cos squared, it is the same thing. It is the same thing, guys. We haven't changed anything there. So meaning the whole part that we are seeing here mathematically from our identity, this one, it is going to give us what? A 1. From here, everything is going to give us a 1. So it means we have a cos of x multiplied, well, this is a product, guys. It's just like times a 1. So cos x times 1 is what? Cos x. Remember, anything times 1 remains like that. So it is the cos of x, exactly what we have on the right-hand side here. Exactly what we have on the right-hand side. It means we have what? Managed to prove this. So this is how you work out your identity. So I want you to just try, guys, as many questions. It is just like, if you do more questions, guys, you just like, even if you just look into the question, you'll be like, you are inside the question. You are inside, you can see what is happening there inside the question. It is because of more practice. All right. Anyways, let's see another question. The sine is squared. All right. Number 3, I'm just going to choose the left-hand side, guys. As you can see, all these terms is equal to 2. The left-hand side is much complicated. So the left-hand side is equal to what? Sine of x plus the cos of x squared plus the sine of x minus the cos of x squared. Guys, algebra did a big job in our mathematics. Knowing algebra, guys, knowing just algebra, it is important, guys. It is important. If you know that a plus b squared is equal to a squared plus 2ab plus b squared. Guys, therefore, we can simplify this because we are just seeing this is our a, this is our b, raised to the exponent of 2. So what are we going to have? A squared, which is the sine, so it is going to be what? Sine squared. The sine of x squared like this is same as what? As sine squared x like this. All right, I talked about this previously. So you're supposed to understand this, guys. All right, plus what? 2ab. So it's plus 2ab. Our a is what? The sine of x. Our b is what? The cos of x. Plus what? B squared. Our b is what? The cos. So it's going to be cos squared of x. You've expanded, guys. Or you can just open 2 brackets. You expand those 2 brackets. Still one and the same. We have the same thing here, the same identity here, raised to the exponent of 2. Take note, guys. It's an addition. So addition does not affect. That's why I'm not opening a bracket here, because you're under addition. But if it is a condition where there's a subtraction, there you must open a bracket to show that you are going to affect everything by the negative. But for a positive, do not worry. All right? For this positive. But we need to expand this identity. All right? Remember your algebraic identities. If it is a minus b squared, it is going to give us what? A squared minus 2ab plus b squared. So as you can see, it is the same thing as this one, only that we are going to have a negative here. Here, there's a negative. Minus 2ab. It was plus, here it's minus. So we are going to just have the same thing, guys. Nothing has changed. It's sine and cos. Nothing has changed. So it is going to remain as sine squared of x, but we're going to have minus this time. Instead of this 2, we are going to have what? A minus. So it's minus 2 sine of x cos of x plus b squared. The last term is what? B squared. So our b is the cos, so it's going to be what? Cos squared. Everything is going to remain as it was before. Only here, the negative there. The negative. When it is negative, this one is negative. When this is positive, this one is positive. That is the only part that changes. Guys, we are back to our algebra, as we can see. So mathematics is a continuation from one topic to another, as you can see. So revise your topics, guys. Do we have any like terms? Any like terms? If they are like terms, we can add the like terms. Or if they are identities that are proven mathematically to be correct. We have something, guys, sine squared, cos squared. That is something that we have. Remember, sine squared x plus the cos squared of x is equal to what? To 1. So once we see that here, like here, we can see it. Sine squared of x here, and this cos squared of x. If you add these two, sine squared plus cos squared, you get what? A 1. So meaning to say we have a 1. So we are going to have a 1 from these two. We also have another one. If you check properly here, there is a sine squared here. Another one, sine squared of x here, cos squared of x here. This one. Sine squared x plus cos squared x gives us what? A 1. So we're going to have another 1. So that's plus 1. All right. These are also like terms if you consider properly. 2 sine x cos x minus 2 sine x cos x. What are we going to have? 2 minus 2, that's a 0. So these two, we're going to cancel. 2 minus 2. So this one and this one was going to cancel. So you're going to remain with what? 1 plus 1. What is 1 plus 1? That's a 2. This is what we have. A 2. Exactly what we are given here to say our answer is supposed to be what? Is supposed to be 2. So this is what we have on our right-hand side. So that is just like that, guys. All right. So just work with the complicated side as much as you can on that complicated side. You are supposed to get the answer that you are given there. If so, actually in this type of a question, you already have the answer, guys. So if you are not getting that answer, if you are not getting the answer that you are given, which is a 2, it means it is wrong. Work until you get that answer. This is the most interesting part of the proof, guys, proving of our identities. This is the most interesting part because already you have the answer to say, my answer is supposed to be this. If I work out, I'm supposed to get a 2. So if we are to work out this question here on question number 4, the left-hand side, we are supposed to get what? A 1. This is what exactly it means. All right. So let's say number 4, working with the left-hand side. This is what we have on the left-hand side, 1 minus the sine squared of x. There is a bracket there, 1 plus the tan squared of x, all right, like this. All right, so let's try to figure out what is happening here. Can we expand the brackets? Because if we are to expand, there'll be a product of a sine and a tan there by just looking into this question. Because, guys, remember, it's a proof. Remember, it's a proof. So also as an individual, you must try to figure out. You must try by all means to figure out if I'm to expand this part, is it going to help me? So you can see it's going to be complicated here, expanding like because of this here and here. What are we going to do? Let's say we've got a sine squared x and a tan squared. How can we simplify this? Because it will be like this. Sine squared times, remember, tan squared, it will be sine squared of x over cos squared of x. And these two cannot cancel. So it's going to be complicated to work with. So let's put away the mind of expanding. Let's just work as a bracket as it is. How can we simplify as a bracket as it is? This is what I'm trying to say. Look into this bracket, simplify it into the simplest form. So someone is going to ask, is this not in simplest form? In our case, it is in simplest form, yes, but remember that we said the sine of x squared plus the cos of x squared is equal to 1. So they just made this one, 1 minus, they just transpose to have 1 minus, they took this one to the other side. They took to the other side. So it remains that we're going to have what? Cos squared of x is equal to 1 minus sine squared of x. In the same manner, guys, we can do it for sine. We can take the cos squared to the other side. So we remain with what? With sine squared. So it will be like this. Sine squared is equal to 1 minus cos squared. These are extended from this one, our Pythagorean, the way that we know it. So once we see a 1 minus sine squared like this, we can take it at least to be what? Something simpler. Cos squared, guys, is simpler to work with. It's a single term. Something that is simpler in our case. So let's just take this one and see where is it going to lead us. This one. From what? This. It's cos squared. So that is the cos squared of x. It is a single term as it is now. We now have it as a single term. All right, this one. It's now a single term. Let's move on to this one because we still have another bracket here. There is no replacement for a tan squared from these two here because we've got sine and what? Sine and cos here. But we know a tan is equivalent to what? To a sine over a cos. Sine of x over a cos of x. This is our tan. So when we are given it as a squared like this, you also have to square. When it is a squared like this, you must also square this one and also square this one. This is what it means. So it simply means we are having 1 plus the tan squared can be written as this, sine squared over cos squared. So that is sine squared of x over the cos squared of x, like this. This is what we have. All right. In this bracket, we have to simplify further. So let's look into our brackets and simplify further. Just addition, as you can understand, guys, your addition. And also as part of your addition, guys, you are supposed to be very careful. All right, let me just write this one as it is, cos squared of x. Then we simplify this one. So as I was saying, it is very true, guys, that you are working with an addition. You are working with an addition. Let's check our final answer here, the way that it is. Let's check our answer. Our answer is supposed to be what? Our answer is supposed to be 1. This is what we have. Our answer is supposed to be 1 as our final answer. All right. So it is either I can just multiply throughout the bracket or I can add. That is the option that we have in this case. We can combine this or we can just expand the brackets. So actually expansion can be easier because of our answer there. Expand this, cos of x multiplies here. It is going to be what? Cos squared of x. The cos of x multiplies here. So it will be like this. I want you to see it will be like this. Cos squared of x times sine squared of x over cos squared of x, like this. So this is just same as over 1. So the cos of x and the cos of x was going to cancel. You remain with what? Sine squared. So this was going to give you the sine squared of 1. So remember that sine squared plus cos squared is what? Is 1. This one. From here, we obtain a 1. So when we have cos squared plus sine squared, we know that our answer is what? Is 1, which is exactly what we have on the right-hand side as we saw previously. So this is how we can simply work out our questions. All right, let me just leave this part, guys. As you can see, I've been rewriting this part. So this is your question, guys. Let's check another part on question number 5. Again, to prove. So, guys, the proof of identities is just one of the simplest part in your mathematics. If you work out as many questions, you see that this is the easiest part that you have because already the answer is there. You have an answer. All right. So on number 5, we're going to choose which side to work with. The complicated side. Can choose the left-hand side, which is much complicated in this case. So our left-hand side is equal to 1 over the sine of x minus the sine of x. Sine of x, as it is just like representing a single term, just like a whole number. So you can write it as sine of x over 1. So guys, let us just combine our fractions and see here. From our fractions, we do understand we need the LCD from the given denominators, sine of x and 1. We are going to use the sine of x. So that is the sine of x. Guys, do not forget your simplification of fractions. Sine of x divide to sine of x. That is going to give us 1. Whatever that we get, we multiply to the numerator. So it's sine of x over sine of x. It was going to cancel, you get a 1. So 1 times 1, that's a 1. So it was going to be 1 times 1. All right. Let's do the same thing. The sine of x divided to this 1. It is going to give us what? Sine of x. So it was going to be the sine of x times the sine of x, which is already in the what? In the numerator. We already have a sine of x there. So let's simplify. 1 times 1, that is 1 minus sine times sine, which is what? Sine squared of x. Everything over what? Over the sine of x. Remember, when we are working addition and subtraction of fractions, you keep the LCD, the LCM throughout. You keep that one throughout. So let's simplify, guys. With our simplification, the answer that we are having is a single fraction, cos over tan, a single fraction. What happened? We cannot separate this because we need a single fraction. So we cannot separate because remember, a minus b over c, I said in our algebra, is same as a over c minus b over c. But we cannot use this part because of our answer. Guys, that is the most part of what? Proving. You are checking also your answer. Your answer is a single fraction. So meaning to say there's something about this here, about this one. 1 minus sine squared. Let us have it as a single term. Remember, 1 minus sine squared is equivalent to what? Cos squared. So in place of this 1 minus sine squared, we are going to have the cos squared of x over what? Over the sine of x. This is where we are. This is where we are, guys. But remember our answer there. Cos over tan as a single fraction. But as we have a cos, we have a sine. All right, let us figure out, guys. Remember, cos squared means there are 2 of them. So it is just like cos x times cos of x over the sine of x. This is what it means. If you understand, guys, that when you are given a product a, b over c, it can be separated as a over c times b. Or it can be separated as a times b over c. For a multiplication, one of the given terms in the numerator carries the denominator. When it is like this, it is different from addition and subtraction, guys. A plus b over c. You are going to have it as a over c plus b over c. Everything carries the denominator. Everything is separated by the denominator. Here it is different. You don't separate this one as a over c times b over c. Guys, the moment you do this, look, a times a gives us what? I mean, a times b, that's ab. C times c gives us what? C squared. So it's totally wrong. It's not what you had originally there. Because it's going to give you what? C squared. So when it is under a multiplication, one carries the denominator, one of the given terms. So understanding this, guys, it means we can separate the sine, I mean the cos here and the sine. One of these carries what? The denominator. That is what it means. One of these carries what? The denominator. So what it simply means, we're going to have the cos of x over what? The sine of x times the cos of x. This is what it means. Cos of x is, guys, just same as cos of x over 1. Just like over 1. So this is what we have. This is what we have, guys. Cos over a sine. This is different from what we are given because we can see on our answer there's a tan. What happened? Remember, guys, you're proving the mind of the person who's we had to give the question, guys. It's like someone was answering this. So you want to figure out what was that person thinking. This is the idea of this question. So according to our answer where the tan is, let's go back to the tan. We know that wherever a tan is, it is equivalent to what? Sine of x over the cos of x. We do not have that here. We have got cos over sine here. This is cos over sine, this one. This is cos over what? Cos over sine. What do we understand by cos over sine? If it is cos over sine, that is 1 over tan. The reciprocal. Okay, let's go back to our mathematics, guys. The moment you say 1 over this, let's go back to our basics mathematics. 1 over tan x means the reciprocal of a tan. So meaning to say, the moment you say 1 over this side, what happens? 1 over, it is interchanging, you invert. So it will be like this, cos of x over sine of x. So it is not a mistake to have cos of x over sine x because it is equivalent to what? To 1 over tan x. We are no longer working with those cot of x, guys, as we had in our grade 10. Yes, if you want to use that cot of x, you can use it. Remember that 1 over cot x is equal to tan x from our grade 10. We can use that. But in this case, I want us to basically work with our identity of tan. Sine over cos. It's reciprocal. It's cos over sine. So when you see this cos over sine, what are you seeing? Cos over sine. You are seeing what? 1 over tan. So this is 1 over tan x times the cos of x over what? Over 1. This is where we are. So guys, we can simplify this further. 1 times cos, that will be cos. Over what? Tan times 1, that is going to be tan. So it will be like this. Exactly what we are given on our final answer. Like I said, to prove you are given the answer, guys. So this is exactly what we have on our right-hand side. So these are the typical questions that you need to work with. We are going to add more questions. So this is part 1 of the proving of identities. This is the part 1. We're going to have part 2. I don't know where is it going to end, but we're going to work with much questions on the proof. Then we move on as we have our trigonometry for term 1 until we reach to the end of it. So make sure that you become part of this family, Meson African Motives, and to follow the playlist, guys. As we've got the playlist, we are going to be having these classes following each other. So we'll see from there. That is it, guys. Till we meet again.